All right, let's look at some review questions for Chapter 9 on the Sun. Here's question number 1. The visible light we see from our Sun comes from which part? Which part of the Sun does it come from? Well, we know that the energy comes from the core, but what we actually see is a part of the Sun that's a lot cooler than the core, and it's still a lot hot compared to us. That's the surface of the Sun. That is the photosphere, a very thin layer on the outer portion of the Sun. Temperature of about 6,000 degrees Kelvin. Question 2. The density of the Sun is most similar to that of? Well, we know that the Sun is maybe about a quarter of the density of the Earth. It's actually less dense than the Earth, except towards the center it's very dense. Towards the outer portion it's 1/10,000th the density of air. But on the average, it's about 1.4 times the density of water, which is just about the same as the density of the planet Jupiter, suggesting that they have similar composition. And Jupiter does have a composition, mostly hydrogen. Jupiter would have been a star if it had 20 times more mass, or a better agent, it could have been a star. Question 3. The Sun is stable as a star because we have all this energy being thrown out from the Sun, which is creating a pressure, forcing material outward from the Sun, and ultimately in convection at the outer expanse. But the Sun has a lot of mass, and it's been pulled into a ball-like form, like a sphere, and so this balance between gravity pulling in and pressure pushing out is what we call a hydrostatic equilibrium. So gravity balances the forces from the pressure, and this was something that happened early in the Sun's life to create this hydrostatic equilibrium. Question 4. The proton-proton cycle involves what kind of fusion process? In the proton-proton cycle, we're fusing hydrogen, which is just protons in this nucleus, into the second element of the periodic table, helium. So we're going from hydrogen into helium, losing a little bit of mass, converting it to energy. 4 hydrogen nuclei fuse into one helium nucleus, releasing gamma ray energy and neutrinos. Question 5. A neutrino can escape from the solar core within minutes. How long does it take a photon to escape? This is a good question. I don't believe I mentioned this in our lectures, but a photon can be trapped within the absorption and the convection zone for many years. I'm guessing about 1 million years. So a very long time. Photon can be trapped as it goes through these cycles in the convention cycle, eventually changing to a lesser amount of energy in the form of visible and infrared light at the surface. Question 6. What is probably responsible for the increase in temperature of the corona far from the Sun's surface? Well, far from the Sun's surface, we know that it gets up to about 3 million degrees Kelvin in the corona, and that's higher than it was in the transition zone and much higher than it was at the surface. So there's something supplying energy to the corona, and that is the Sun's very large magnetic field. It's acting like a pump that is giving energy to those particles and allowing them to reach the higher temperature, higher movement, and higher temperature. It's the Sun's magnetic field. Question 7. The number of sunspots in solar activity in general peaks. We're talking about the cycle, and the number peaks every 11 years, but the full cycle of the Sun's sunspot number, sunspot number is every 11 years, but the full cycle of the sunspot activity is 22 years as the polarity of the poles reverse. But we're only talking about the number here. So our one answer that we possibly can choose is every 11 years. Question 8. The solar neutrino problem refers to the fact that astronomers, well, the neutrino problem was associated with searching neutrinos to discover that this process of fusion was actually what's taking place in the center of the sun. It's pretty straightforward idea that it is, but we want to confirm that idea. And so you look for a certain number of neutrinos, which are very hard to detect in the first place. And in fact, only 1/3 of the number that were expected by theory were being detected. The solution being that they are changing form from one kind of neutrino to another kind of neutrino in their journey to Earth. So the problem was that only 1/3 of the number of neutrinos were being detected as expected by theory. The solution being that they are changing form before they get to us. That concludes this review of clicker questions for Chapter 9, The Sun.